What is the connection between math and logic? Have you ever wondered how mathematics and logic work together? The relationship between these two fields is fascinating and essential for effective mathematics problem-solving practice. Logic serves as the backbone of mathematical reasoning. It helps us establish valid arguments and ensures that our mathematical statements are sound and consistent. Let's break it down. First, we have logical connectives. These are words like and, or, and not. They help us define relationships between different mathematical statements. For example, if we say A and B, both A and B must be true for the whole statement to be true. This simple concept is crucial for building more complex mathematical ideas. Next, we look at propositional logic. This branch deals with statements that can be either true or false. Understanding this helps us see how mathematical arguments are structured. When we analyze a math problem, we often break it down into smaller statements, checking if they hold true. Then there is predicate logic. This takes things a step further by allowing us to make statements about objects and their properties. This is important for expressing mathematical theories and proving theorems. For instance, when we say, all squares are rectangles, we are using predicate logic to make a general statement about a specific type of shape. Now, let's talk about some subfields of mathematical logic. Model theory examines how mathematical structures satisfy certain logical formulas. This helps us understand whether our mathematical theories are consistent and complete. Proof theory focuses on the formal structure of mathematical proofs, giving us tools to analyze and construct valid arguments. Set theory is often considered the foundation of mathematics. It uses logical principles to define and manipulate sets, which are collections of objects. This is essential for formalizing many mathematical concepts. Lastly, recursion theory, also known as computability theory, explores the limits of computation and the properties of algorithms. This is vital for understanding what can be computed and how efficiently. So, how does all this relate to effective mathematics problem solving? Developing logical reasoning skills allows students to analyze problems methodically. They can identify patterns and construct coherent arguments, which are essential for tackling complex math problems. By applying logical principles, students can evaluate different approaches to solving a problem. They can assess the validity of each method and choose the most effective strategy. This systematic approach is key to improving problem-solving skills. Moreover, using logical language helps students express mathematical ideas clearly and accurately. This is crucial for effective collaboration and problem solving. Finally, logic aids in recognizing patterns and relationships between different mathematical concepts. This can simplify the process of solving algebraic expressions and equations. Incorporating logical thinking into mathematics study techniques can significantly boost problem-solving skills. It enhances analytical abilities and promotes systematic approaches to mathematical challenges. Understanding the connection between math and logic is not just interesting, it is a practical tool that can lead to greater success in mathematics.